Good morning, viewer. Bien here. Here's the most breaking news for our viewers. A novel MRI technique developed at MIT allows for detailed imaging of bioluminescence deep within the brain, offering new insights into how brain cells develop and communicate each other. Scientists often level cells with proteins that glow, allowing them to track the growth of a tumor or measure changes in gene expressions that occur as cells differentiate. While this technique works well in cells and some tissues of the body, but it has been difficult to apply this technique to image structures deep within the brain because the light scatters too much before it can be detected. MIT engineers have now come up with a novel way to detect this type of light, known as bioluminescence in the brain. They engineered blood vessels of the brain to express a protein that causes them to dilate in the presence of light. That dilation can then be observed with magnetic resonance imaging, allowing researchers to pinpoint the source of light. A well-known problem that we face in neuroscience as well as other fields is that it is very difficult to use optical tools in deep tissue. One of the core objectives of our study was to come up with a way to image bioluminescent molecules in deep tissues with reasonably high resolution, says Alan Jasanoff, an MIT professor of biological engineering, brain and cognitive science, and nuclear science and engineering. The new technique developed by Jasanoff and his colleagues could enable researchers to explore the inner working of the brain in more detail than has previously been possible. Jasanoff, who is also an associate investigator at MIT's McGovern Institute for Brain Research, is the senior author of the study, which appears today in Nature Biomedical Engineering. Former MIT postdocs Robert Ohendorff and Nan Lee are the lead authors of the paper. Behind this exclusive report.